This is the lesson 1.2 visual summary. So they give me some ratios that we've worked with in the last chapter. 1 out of 5 people prefer strawberries. 1 out of 6 prefer apples. 1 out of 4 prefer bananas, and the rest don't like fruit. So when we look at filling in a table, if I need to know for 120, for strawberries, it was 1 out of 5. I'm going to put 1 out of 6 here and 1 out of 4 here. So for this, to figure out the answer, if I know 1 out of 5 prefer strawberries, how many out of 120? So I can scale up, and this is going to be times 24 times 24. So I see that I will get 24 people who prefer strawberries. For apples, it's the same thing. I have 1 prefers apples out of 6 total. So how many out of 120? So here I can see again, I'm scaling up, and I end up with 20. Banana, 1 out of 4. How many out of 120? I can see I'm multiplying by 30. So now when I add these 3 together, I get 74. And there were 120 total. So 120 minus 74. There are an additional 46 then who must not like fruit. So it's using what we know from the last chapter to answer the question. So what they ask me here is, as the total number of people increases by 120, how much does each increase? And let's keep adding these numbers to the table. So again, I'm always looking for relationships. Going from here to here is times 2. So if I just multiply all of these times 2, so 24 times 2, now I know I get 48. 20 times 2, 30 times 2, and times 2. And when we add all those together, I should get the 240. So I'm going to keep looking for relationships. I could do this times 3. So I could take 24 times 3. Or I might see this plus this gives me this. So this plus this gives me this. So we have lots of options. When I do either one of those, I would get 72, 60, 90, and 138. When I'm looking for 480, I might see 120 plus 360 is 480. So 24 plus 72. I might see 240 times 2. I might see 120 times 4. So there's lots of ways that we can get these answers. So it doesn't matter which way you see it. The answers then will come out to be 96, 80, 120, and 184. So question 3 asks, how does the increase in total people as a multiple of 120 make calculations more efficient? And why 120? So what we notice here is if I had some different answers here, I may end up getting decimals and fractions. So 120 is a nice number for me to work with because all my answers are whole numbers. Now another thing I notice is actually because we're using fifths, sixths, and fourths, 5, 6, and 4 all go evenly into 120. So it makes our numbers all turn out a little nicer. So now it's asking us to complete a second table. And I'm going to see some relationships between the first table and the second table. Because I see if I go from here to here, that's just times 100. Or I added a 0. So I can do that for all these numbers. I don't have to set up ratios every time. I know now that this is going to be 240. This one's going to be 20, turns into 200. 30 turns into 300. 46 turns into 460. So now if I look here and here, this just added a 0. So then I can say, well, this was 40, so I can add a 0. I get 400. 60, I can add a 0. 92, I can add a 0. And 240 turns into 2,400. So I'm finding all these relationships. Again, 60 to 600, add a 0 or times 10. So 90 times 10 is 900. 138 times 10, 1,380. Here I'd get 720. And here I'll get 3,600. So I'm just filling in the rest of the table. Okay, so here to here. So this will be 1,840. This will be 800. This will be 960. 4,800. Now here they added an extra table. So I'm going to try to figure out, how did we get to here? So I can look and say that, let's see, what can we add together to get there? So it looks like we doubled, added another 120, added a 120. Let's see if we add another 1,200 to here. I would get 6,000. So I'm going to just keep going up. These are all going up by 240. So if I add another 240 to here, I get 1,200. These are all going up by 200. So if I add 200 to here, I get 1,000. These are all going up by 300. If I add 300 to here, I get 1,500. These were all going up by 460, so I can double check this. If I add 460, I do get this 2,300. So how do these numbers compare to the numbers in the above table? So they are all times 10 from this table. 120 times 10 is 1,200. So the relationship here is, oops, I'm sorry, back here I wrote times 100 in the very beginning. This is times 10. So the relationship going from this table to this table is times 10. So if we go to graph, we want to see what this looks like in a graph. And they're only asking me to graph the total people. So that's the first column in my table. And they want the number who preferred strawberries. So all I'm graphing is this relationship here in the first two columns of my table. So one of the things I have to decide is my intervals. And I'm going to go with 150 for each interval. Now we always mark the lines, not the spaces. So this would be 150. I'm only going to mark in every other just so it's easier to see. So this would be 450. This one would be 600. 750. This would be 900. 1,200. 1,500. 1,800. And if I go up for people, I think I'm just going to go up by 50. So this one here would be 100, 200, 300, 400, 500, and 600. Okay, so now if we start to graph, total people 120, so that's going to be a little less than 150, so I've got to move slightly to the left of that line, and I'm going about where 24 would be. So if this is 50, that means 25 would be half. So this dot is going to be about in that location. And then I have 240 people. 240 is going to be between these two dots, but a little closer to the 300, and that's 48. So that's pretty much going to be almost right in the center. And then we have 360 people. So again, it's going to be between 300 and 450, but closer to the 300. And then I go to 72. So again, it's still, oops, off here. This 150 is going to be just underneath that line right there. So 75 is going to be right in the middle between 50 and 100. And then 480. So this is 450, so slightly over that. And I need 96, which is just slightly under 100. Okay, now I'm going to move to that second, the bottom table. So we had 1,200 and we had 240. So 1,200 is here, 100, 200. This would be 250, so slightly under 250. And then we had, okay, the rest of mine don't even fit on my graph. So what this should look like if we had real detailed graph paper is this line should appear to be straight. And if I had 0 people, I would have 0 people who like strawberries. So I am going to put a dot right down there at the origin. So we have some new terms here. It's asking, is this data discrete or continuous? Discrete data means that fractions and decimals do not make sense in the context of the problem. So we're talking about people for both of these. There's no way I can have half of a person. So in this case, this data is discrete. Continuous means that fractions or decimals would make sense in the context of the problem. It would not make sense to say 1.5 people. So I have discrete data. So the next question is, should the points be connected or not? So here I'm going to make a little note. Discrete starts with a D. It means don't connect. Continuous data starts with a C, and it means connect. So I think typically we're used to just connecting right away when we see a graph, but that is actually a decision we need to make. We have discrete data. It does not include numbers that would fall between, doesn't include fractions and decimals. Therefore, I don't connect. So how did we decide? We decided by saying we can't have fractions or decimals with people. Therefore, I'm not connecting. The only other terms that we have to know is the term direct variation, which will also be sometimes called direct proportion, which will also sometimes be called direct variation, direct proportion, or varies directly. What this means, and these terms are all like really important, is that the points on the graph are straight. So if I could graph this perfectly, these would all look like they are straight, and it must run through the origin. So this runs through the origin because point 0, 0 made sense to the problem, and it is straight. So this relationship does show direct variation. It's direct proportion. They vary directly. The total number of people and the number of people like strawberries vary directly.